supporting the Hyperledger meetup in Berlin. My name is Stefania Artusi, and I'm Berchain Association Manager. And today with me, there's also David Boswell from the Hyperledger Network. And regarding Berchain and what we do, we are a nonprofit member-led association based in Berlin, and we connect and promote the Berlin blockchain community. And we facilitate as well science and research activities, education around the topic of blockchain, through which we promote the local Berlin ecosystem. And if you want to know more, I will be pasting a few links during the event. Today's meetup we'll see presenting Matt Zand, who is the author of Hands-on Smart Contract Development on Hyperledger Fabric. And he will briefly introduce his book to the audience and review the Hyperledger family and its ecosystem. And the session will continue with Matthias Geis from Perun Lab, who will introduce to the audience blockchain scaling and interoperability, an overview of the Perun Framework. I'll go really quickly through the housekeeping. So before we get started, if you wish to actually ask the presenters a question, please click on the reaction icon on the bottom of the screen and select raise hands. There is also an open chat feature enabled, I can see. And if you want to chat also with other attendees, simply click on the chat icon. And at the end of the presentations, there will be 2 Q&A sessions. The first one is for Matt and is starting around 5:20. And the second one is for Matthias and is starting around 5:40. Now, I will just give you a brief introduction about the speakers for today, Matt Zand and Matthias Geis. And Matthew Zand is a serial entrepreneur and founder of several tech startups, and he is leading author of Hands-on Smart Contract Development with Hyperledger Fabric, book by O'Reilly Media. And there's Matthias Geis, who is a principal software architect at Polycrypt and currently leads the development of the Perun project. So I would like to welcome both of them. Welcome Matt Zand and Matthias Geis. So now I will hand over the word to Matt, who is the first presenting. Thank you. We can't hear you pretty good, actually.
Again, thanks again, Stefania and David, for having me in this talk. And I would be happy to talk about Fabric and my book a little bit. I know I typically do presentation in like a little bit longer than this. So I little bit skim through some of the key component of the Fabric and then Hyperledger family. And then you can go and do the kind of the research on your own, or you can get my book to learn more about these topics in depth. So I am Matt Zand. I am the CEO of the Hash Fellow. We do blockchain consulting and development and maintenance services. So in these talks, I'm going to talk about Hyperledger Fabric and how the Hyperledger works. So as Stefania covered my bio, I'll just quickly go. There is no prerequisite, there's no requirement for this talk. Basically, if you know what blockchain is and how blockchain works, it would be good to follow the things I'm talking in this presentation. So I start off by explaining how the Hyperledger family is structured, what are distributed ledger technologies under the Hyperledger family, what are tools and libraries that are under the Hyperledger family, or basically Hyperledger family ecosystems. And then more specifically, I'm going to focus on Hyperledger Fabric, which is the most popular private or distributed ledger technologies for private applications, for blockchain applications. So Hyperledger overview, again, family and then Fabric. So when it comes to Hyperledger family, we can break down the different aspect of Hyperledger family, different component of Hyperledger family into the distributed ledgers and libraries, tools, and domain-specific projects. Domain-specific projects are part of a distributed ledger. However, they are very focused in a specific area, which I'm talking about that. So now I have to admit that you may not know all of this very well, but it's just that if you're doing any Fabric or Hyperledger in production, you may use a couple of libraries and tools that I'm covering today. So the first thing is the distributed ledger technologies that are supported by Hyperledger. So the most popular is the Fabric. Hyperledger Besu and Hyperledger Beru, both of them are part of the Ethereum. So if you are doing anything public blockchain network like Ethereum, and you want to find a way to connect that with a private blockchain network like Fabric, you have to use Beru or Besu. So Besu also support different type of the consensus algorithm, and that's why it's very it's very flexible. And then Beru also support the Ethereum virtual machine. Hyperledger Indy and Hyperledger Iroha, both of them are for identity management. So if you want to build applications, especially Indy, if you're building applications that is meant for managing the identities, like university, credential of a student, things like that, Indy and Iroha are good. Hyperledger Sawtooth, initiated by Intel company as original kind of the project developer of this. And then Hyperledger Sawtooth is focused on performance. And unlike the Fabric, every node on Hyperledger Sawtooth can be a validator of its own. So Hyperledger Fabric has only one orderer or validator, but on the Sawtooth, every node can be a validator. Another advantage of Sawtooth is that it supports different type of the consensus algorithms, like proof of stake, proof of work, blah, blah, blah. So this gives you, again, some advantages over the Fabric. At the same time, there has some disadvantages. Fabric versus the Sawtooth versus the Fabric. Most notably is the community behind the Fabric, right? Which is much stronger, right? Now, with regard to libraries that's supported under Hyperledger family, there is Aries, and there is a Guild, and then there is a Transact and Ursa. So the thing is that Hyperledger Aries for identity management. Again, this is a library that if you want to manage the identities, you can easily connect these libraries to your Fabric project. That's very important to know. Hyperledger Guild is interledger protocol. If you want to do any payment processing, anything like that, trade finance or things like that, Hyperledger libraries like Guild is good. And Hyperledger Transact allows you to do platform agnostic smart contract development. In other words, if you're building a blockchain on a Fabric, you have to use chain code or smart contract and maybe its own kind of the language like Go, like for example. And if you're using Ethereum, you may use Solidity programming languages. On the other hand, if you want to build a smart contract, which is a platform agnostic, meaning that it works on any platform, then Hyperledger Transact would be a good library to use. Hyperledger Ursa is for security. So if you want a little bit add more security to your Hyperledger application, you can also use this library. Well, regarding the tools, Hyperledger Avalon, there is a Hyperledger Avalon, and then there is a Hyperledger Calibers and Cello and Explorer. Hyperledger Explorer has been deprecated, meaning that's not supported anymore for almost 2 years. It was very beautiful. It was a very great tool for monitoring the Fabric network, but it's not maintained anymore. And so Hyperledger Avalon is for managing off-the-chain data. So as you know, there are some data stored on the chain and there are some data stored off the chain. So you can use Hyperledger Avalon to securely create a bridge or API between your off-the-chain data and on-the-chain data. Hyperledger Caliber is awesome. It's a great tool for performance monitoring. Like how's your network performing, if a node is down or something like that. And then Hyperledger Cello if you want to automate some of your admin processes in the Fabric, you're managing credential, setting up the network, or bring up the service, or shutting down the service, all things normal admin tasks. If you want to automate them, then Hyperledger Celo would be a good tool to use. Now, with regard to domain-specific project, Hyperledger Grid is very good for managing supply chains. So this specific this DLT, or distributed technology, is used for supply chain management. So we can also explore that. Now, before I leave this DLTs and tools and libraries, I have to emphasize and mention that some of these tools and libraries are still at the incubation stage. So make sure check, because I suggest not to use them in your production if they are still at the incubation stage. So it may cause some interruption into your operation. So for proof of concept, if you are experimenting with some concept, you can use all of them. Now, regarding the Fabric, so Fabric is the most popular distributed ledger technologies under the Hyperledger family, and is also very popular for private blockchain network, right? And then it's managed by Linux Foundation and Hyperledger Foundation, and it's also meant for enterprise level blockchains, permission blockchain applications, which means that one of the things about Fabric is that the architecture of Fabric and component is a little more difficult and different than Ethereum, and it has a little bit of the learning curve to learn how the Fabric is architectured. On the other hand, as your project requirement increases, as your project requirement become more and more advanced and complex, then you start appreciating the Fabric, because at the very beginning, from day one, Fabric was meant for enterprise application. So now the thing is that another aspect of Fabric is that it's called Hyperledger, means multiple ledgers. It supports private data collections. It has more, again, as I said, that has more kind of the tools and more kind of the component and features that are meant for large scale. And also, you can also build a Hyperledger Fabric smart contract in different programming languages. And if you have multiple smart contracts, so the name chain code and a smart contract, they go hand in hand, they're the same. It's just that if you have multiple smart contracts, and then if you want to wrap them together, you can use the wrapper inside the chain code in the Fabric, and then you can use JavaScript or Go, different programming languages, Python or Java. And about my book, well, in my book, we spent a few months to come up with the list of topics that are very practical, right? So we started off covering the key component of the blockchain technology, the nitty-gritty of blockchain technology, how it works. Then we start talking about all the family ecosystems like tools and libraries that I discussed it earlier. And then we talked about Fabric component, which a little bit I'm talking about later in the following slides. But in our book, we talk about those components more in detail. And the core of our book, I put it this way, is developing, testing, debugging, and deploying a smart contract in a Fabric. And then after that, once you do that, how you want to deploy it on the cloud. So we cover, AWS, IBM, Azure, and Oracle. It's just that the thing is that we also cover like some of the things that you need to know. So these two areas are also practical. So meaning that once you most of the Hyperledger Fabric application currently in productions are using the older version of the Fabric. So I had another presentation a few weeks ago regarding how you can upgrade your Hyperledger application to the latest version, so version 2, and what are the things you have to take into considerations. And so basically, in our book, we have one chapter on talking about Fabric 2 version 2 features and migration. And then we have also one kind of the end-to-end pharma supply chain consortium is like hands-on step by step how you can build from A to Z one Fabric application, which is supply chain for pharmaceutical. And then in the last chapter of the book, we talk about Hyperledger Aries, which is for identity management. And then we talk about Hyperledger Avalon for off-the-chain data management. And also Besu, which is for Ethereum, and Grid for the supply chain. So we covered this because all of these are at the production level. They are not incubation. They are active projects. They're active. Well, again, due to the lack of time, I just skip some of this slide because you can go back and read, because it just talks about differences between private blockchain and public blockchain networks and why privacy matters. And very high level overview, very quick, is that Fabric has different component peers or nodes where the organizations exist in the network. Ordering service act as a regulator, or sometimes called orderer. And then certificate authority is in charge of issuing certificate, because you cannot participate in a blockchain without having a right certificate. Certificate is going to tell you what you can do, what you cannot do. And then Fabric ledgers, and then channel. Channel is like a subset of, is a form of ledger or subset of the node that they communicate with one another to conduct some form of transactions. And then a smart contract I already covered. Endorsement policies, just part of the policies. There's so much stuff going on in the Fabric policies. Endorsement is like consensus, which is going to tell you that under what circumstances a transaction need to be accepted in the network. And the membership with service providers is just in charge of managing all the identities in the network. Well, you can go back to my slide later if you want. I can give you a link and then just read it. It's just that I just want to give you a very high level overview. The job of orderer is to receive the transaction, sort the transaction, send the transaction to the party that need to receive that, validate them, and then add that transaction into the ledger and gossip or broadcast back to the rest of the members of the network, so that they know that this has been successfully conducted. So that's the orderer, right? And then a peer can be for any organization which is a member of that. And then one thing is that regarding a channel, each organization in a Fabric can be a part of a different channels, right? Can be one, two, three different channels. And the channels in itself add some complexity to the Fabric architecture, because each channel can have its own smart contract, has its own policies, has its own data sharing. Again, and validations or things like endorsement. And then, as I said, and then we have for member service providers, which is in charge of the identities, we have one root admin, which is in charge of the main certificate, and then we are like hierarchy. Main admin at the top, and then it comes down to all the other players or members in the network. And then also like that, we have something called system channel, right? So very quickly, as you see that there's a system channel who's in charge of the whole network, and then we have an orderer or regulator, and then we have different organization which is part of that. And there can be several channels depending on what type of the data they are communicated by what parties in the network. And then as I said, the chain code is in charge of the managing the chain code need to be installed on each node, and chain code support the state database as well as the ledger data. Ledger data is immutable, meaning that ledger data cannot be changed and usually saved in a log file. State databases can be altered, can be changed, and be updated. By default, Fabric supports level DB, but CouchDB is highly recommended. The latest version of the Fabric support CouchDB with cache, which improve the performance. And then as you say that inside each node, we have a state database, and we have a smart contract, and we have a ledger. From outside, you can query that. And then we have something called over here, it's called off-the-chain database that communicate with the node. And then for any participant who want to invoke that kind of the chain code, they can also have in the version 2 of Fabric, there's something called external chain code launcher. And also there's another things that you guys need to watch for it. It's called chain code life cycle management. So if you want to manage your smart contract lifecycle professionally, just look into the version 2 of the Fabric. So basically in this talk, we learned about Hyperledger family, meaning that the distributed ledger technologies that are supported under the Hyperledger family and its ecosystem, and then what are tools and libraries that Hyperledger support and offers. And then we also talked about Hyperledger Fabric component. And then we also briefly talk about my book and some of the highlight of the topic that are covered in my book. And so there are some links and resources if you want to learn more. I have written a lot in the blockchain community since look at some of my articles. And then again, if you want to learn more in depth about the topic I discussed today and more, you can check out my book in Amazon. And then if you have any other questions about Hyperledger project that you have, you can contact me on LinkedIn, or you can check out our website, some of the projects that we are working. And then again, I'm ready to take you in your questions.
Thank you, Matt, for your presentation. If there's already some questions for Matt, we can give it 5 minutes max.
Hello, I have a question, please.
Sure.
What language are used in the project inside your book?
Oh, we are using very simple. In our book, we are using JavaScript, very simple JavaScript.
How about interconnecting two different blockchains like Ethereum and the Fabric?
Sorry, what you're saying is that you see, for the Ethereum you use Solidity, right? JavaScript. For the Fabric, you have different choices. You can use JavaScript, you can use Java, Python, or Golang.
I mean, if I want to make an application that make use of two different blockchains, like example, Fabric for internal asset management, and
yes, I got it.
And
yeah.
Ethereum for paying.
Exactly. So good question. So basically, if you want to do that, you can use the Hyperledger Besu. It's a Hyperledger Besu, right? Hyperledger Besu can work with hybrid projects, right? Public and private, right? You can use Hyperledger Besu, or you can use one of the libraries that I covered, that you can usually use that library, like Perun, that you can connect your private blockchain network with your public blockchain network. So you need to create a hybrid. You can use the hybrid Hyperledger, like Hyperledger Besu or Perun. Does that make sense?
What kind of bridge will be used to link the two?
So it's called Hyperledger. It's called Hyperledger Besu, BESU. Just check it. Hyperledger Besu, BESU.
Is it decentralized like others?
Yes, it's decentralized like others. Is just work. It's just stand between the Fabric and Ethereum, and let them communicate with one another.
Thank you very much.
If I can add, Perun is also something that might be interesting for you in this case, because Perun can also, which I will talk about next, can also give you some interoperability between blockchains. So just a small remark.
Yeah, exactly. There are some solutions like that available outside too to do that, because that's hybrid blockchain is very hot topic nowadays. So we can, Matthias can also give you more insight on that. Any more other questions?
We have another question from Meran. Hi, Matt. Thanks for the nice presentation. Is there any good alternative for HP Composer?
HP Hyperledger, HF Hyperledger Composer. So that's a good questions. Actually, I get these questions because Composer was deprecated. So Unfortunately not, but for example, IBM has its own console inside IBM, and I'm not sure AWS might also have something like that that help you to monitor the network. But unfortunately, there is nothing exactly like the Composer. It used to be Composer before, right? You can everything can be done on the UI, right? There is nothing like that. But again, if you're using IBM has its own console, UI console. You can do that. Oracle has its own UI inside the platform. I suggest you look into those, the UI, the platform cover. Another question is, how can one start learning and get some hands-on experience? Again, if you want to learn, the first thing you have to know how the blockchain works. And if you know that, then I think you can get the book like mine's, or something like that, that you start. I think this next step after you know in blockchain, you have to pick up the platform. If you want to build a private blockchain network, Hyperledger is best. My book would be enough for you to know it. But if you want to do anything like a public, so pick up the book for Ethereum, and you can learn it. And okay, if you want someone who develop the development, so if you want to develop to the Hyperledger project, join the Hyperledger Wikipedia page. And there is a Hyperledger have a very good community. You can join the developer community, then they're gonna accept you under GitHub, then you can contribute to the project. And okay, and then is there any other question?
Yes, I have a question. Hi, thank you very much for the presentation, Matt. My question is this: I want to take something away from this meeting, and can I get some more explainer on what the ODRA does? I understand that that's part of the components of the Hyperledger fabric, and I assume that these components also common to all other family members of Hyperledger. So I don't know what exactly does the ODRA does. How does it work?
So the orderer, again, in a very simple language, is that so basically the way that the blockchain works is like this. So the transaction comes, and there is no intermediary, right? Transaction comes, they need to be validated before they add to the ledger, right? So someone need to act as intermediary, right? Take the transaction, validate them, and add them to the ledger, right? That's the job of orderer, right? The orderer orders and validate and add the transaction to the ledger. Does that make sense?
Absolutely. Thank you. Thank you, Matt. Thank you very much.
Thank you, Matt, for the time you took to answer the question and for your presentation. I would say I'll hand the word to Matthias now.
Okay, sure. And then again, one thing is that thanks again, Stefania. I have another talk in Hyperledger Community DC. I have to jump on that in 10 minutes. So, but again, if anyone have a question, just add me on LinkedIn. I would be happy to answer them after this presentation. And thanks again, Stefania. Take care. Bye.
Thank you, Matt. Bye.
Bye.
All right. Yeah, I'll share my screen. So, can you see it?
Yes.
All right. Good. Then I will start with my presentation about the Perun Framework. So I think we got a pretty nice overview from Matt about what all exists in Hyperledger. And yeah, there are so many libraries and tools that you can use. And Perun is a Hyperledger Labs project, so we are not a full project yet. We joined middle of last year. And the Perun Framework, summarized in one sentence, is for enabling scalability and interoperability through state channel technology on and across blockchains. So the goal is to get more scalability and interoperability between blockchains. And the framework is designed in a way so that it can work with arbitrary blockchain backends. So you can use it with Ethereum, you can potentially use it with Hyperledger Fabric. The framework core is a concrete set of protocols, but you can plug in arbitrary backends for which you have a backend implementation. I will explain a bit more on that in a second. The project originated from a series of research works which focused on how can we scale Ethereum, for example, how can we scale big blockchain networks, And this research started at TU Darmstadt in Germany. And very early on, Bosch joined as an industry partner. And since then, end of last year, we founded a small startup company out of that project, which is called Polycrypt. And that's basically where we currently are. So just a few words also what Polycrypt does overall. We have the Perun product stream, which focuses on scaling peer-to-peer interactions. So for example, if you want to have a high number of transactions between a small number of parties, which is a fixed set of parties, like, for example, you want to do micropayments, or you want to realize some gaming logic where you know there are a fixed set of participants and the outcome should be paid out in some sense over Ethereum, then Perun is a very good solution for that. If you are more looking on scaling marketplaces and trading NFTs, we have another product stream for that, which is called Nerd. And this focuses on another technology more similar to roll-ups. But Perun is based on state channel technology, and this is what we will focus on today. We also do consulting and develop prototypes for customers. So if you have interest in that, any type of researching, scaling solutions for blockchains for your application, let us know. So what problem is the Perun framework tackling? The first thing that it tries to solve is scalability. And that this is an issue, maybe many of you know already, but I will briefly summarize the situation. So especially on the public large blockchains, Bitcoin and Ethereum, we have a certain transaction throughput limit. And this is about 5 to 15 transactions globally per second for each of these networks. And this is just the limit that you can reach with these technologies, because you need to distribute all the transactions across the whole global network. The settlement takes time, at least one block mining, and in Ethereum it's a bit quicker. It takes about 15 seconds for mining one block, and Bitcoin is more like 60 seconds, but it's, depending on the use case, quite a considerable amount of time. And fees, of course, because there are such high loads nowadays on these networks, fees have been rising and rising, and converted to US dollar, you have several dollars of fees, at least, even for the most simple transaction. And on top of that, the fees are varying a lot, depending on the load of the network, which we can see over time. The fees definitely seem to be going up for Ethereum. And the second problem that is a rather more recent one, but maybe as well important as the scalability problem, is the interoperability between different networks. So we have Ethereum nowadays, which is a large blockchain network, very widely used for decentralized finance applications. But there are many more blockchain networks coming up, like Binance or like Polkadot, which I indicate here. And natively, these networks or users on these networks cannot transact with each other. And this is also something that a question on the previous talk was referring to, I think. And this is also something that we are addressing with the state channel technology. So now I would like to give you a very rough idea how that works. So consider we have two clients and they decide that they want to interact with each other. They want to do some transactions with blockchain tokens, but they like to do it at a high volume with a lot of transactions in a short number of time and at low fees. And the prerequisite for this is that they need to deploy the Perun smart contract on the blockchain that they are targeting. And the Perun smart contract will act as an adjudication mechanism. It will basically act as an entity a decentralized entity that withholds the funds that are then available in the transaction channel that the parties open, and it will also resolve any disputes that the parties may have. So how does that work? Once the parties decide they want to interact with each other and open a Perun channel. They deposit a certain amount of funds. They make an agreement. Okay, we want to have 10 Ether each in the channel, and we want to be able to trade off-chain on the second layer. So once they deposited the funds into the smart contract, they can consider the Perun channel on layer 2 open. And now the Perun channel technology gives you a guarantee that any state or any transaction that you do on the second layer without interacting with the smart contract can eventually be redeemed on the smart contract and be paid out. So we can now achieve, without any interaction with those ledger peer-to-peer payments, at basically unlimited scalability without any costs, because it's just sending network packages over the internet, for example. We also can extend this construction that the clients are even swapping assets between different networks. So Alice, the party on the left-hand side, the client on the left-hand side, could be sitting on Ethereum, and Bob, who could put funds from the Binance Smart Chain network or Polkadot into the channel, and they could still interact with each other. And the smart contracts, in this case, would have to be deployed on both chains and would guarantee that any interaction, any agreement that they take off-chain will eventually be resolved on both of the chains. And so they can atomically trade across chains. All of this is based, as I said, on a series of research results, and we have a security proof for the protocols that our library builds on. And either in the optimistic case or also in the pessimistic case, at some point, at least one of the parties will decide that they want to settle the channel, and then they will go to the smart contract, and the result of the off-chain agreement will be paid out. So that's the rough idea. So what does the Perun framework consist of? At the core of the framework, there's the Go Perun library, which you can see in the middle. If you have a full client, you will directly write an application that talks to the library, Go Perun library directly. If you have a light client, like an IoT client, for example, or just a web browser client, then you will probably interact through a node. And we have several nodes available that can make the Perun technology work on light clients as well. At the core of the Go Perun library is the state channel logic. So these are the protocols that are described in the papers. And we implement these protocols against abstract interfaces. So especially the blockchain interface is just the blockchain connection is just an abstract interface, and you can implement that interface for your favorite blockchain. We currently have implementations for Ethereum, for the Cosmos network, and for Polkadot. We are thinking about adding a Hyperledger Fabric implementation as well. This works for almost any blockchain. So you can write your clients somewhat independent of what kind of blockchain you want to use in the end. And this is also true similarly for the network, for the messaging between the clients. We are not fixed on one specific mechanism. We can either send messages via TCP/IP, or you can plug in your favorite message broker. The same accounts for persistence layer and the logging layer as well. So we really try to design the library so that you can make it useful in any scenario or application context that suits your application the best. To give you a very rough idea of how the code looks when you work with this library, the library is written in Golang. So the first line, we have some prerequisites which we need to instantiate. The bus is the messaging layer. Then the layer that, the component that does the deposit in the beginning, that funds the channel, is one object. Then the adjudicator, basically the abstraction for the contract logic, for the adjudication of the channels. If the channel should be settled optimistically or pessimistically in a dispute case, this is done by the adjudicator object. We have a wallet abstraction, which abstracts the accounts and needs to be implemented depending on what blockchain you use. And we have also some external watching mechanism, which does some additional work on behalf of the client. But basically, you can instantiate these objects depending on your needs, depending on the application context, and then create a Perun client out of it. And this client then needs to watch for incoming channel proposals or incoming updates on an already open channel. The client can also be used to open a new channel. In this case, this is a specific type of a channel called ledger channel. It's the most basic type of channel. So to do that, we can call propose channel, input the proposal that we generated, and it will contact the clients written here in the proposal. So in the proposal, you would say, I want to open a channel with that client at that address. And the proposal will contain that information, and the library will open the connection with that client and establish a parent payment or state channel. And updating the state and doing payments via a channel is by the method update by. So you can specify how you want to do a payment or some arbitrary logic on that channel. And this is done here. And if you're done with transacting off-chain and want to redeem your funds on-chain, then you can call settle. So that's the very rough idea. How are we doing with time? Yeah, I think this should be fine. So I also have a small demo video that shows you how that works, how that looks as in a browser. So we have two clients, one on the left, one on the right. This is on testnet, I think. So you click on one client, you can now decide if you want to open a channel with another client. You paste the address of the client. You enter the funding of the channel that you want, the amount of funds that you want to have available. And then when you send it, the proposal will be received by the other client, and he can either accept opening a channel and putting the funds into it, or he can reject it. But in this case, we will accept. Then, of course, we both have to formally agree via a signature. This is done via MetaMask signatures here. And now the channel funds will be deposited, and the channel will be ready to be used off-chain. So now we can send, for example, here, 3 Ether from one client to the other. We have to confirm that with the signature. And as you can see, immediately the transaction will be visible on the other side. We have to confirm that we want to receive this, the funds via the channel. And within an instant, this transaction is confirmed. And I think we do another transaction here from the right client to the left client with a smaller amount. Again, we sign it. Yeah, so we sign it and countersign it. Both parties have to agree. And then when we are happy with the result, we can close the channel. This is again requires a signature. We need to indicate we want to close the channel now. The other party will accept. And then the funds will be transferred on the contract and will be available on the global public blockchain once the channel is closed. Yeah, so that's the flow that the channel protocol works. And that's also, basically the end of my presentation. I want to summarize here. So what you should have learned today is that the Perun Framework is a toolkit for enhancing scalability and interoperability for blockchain applications. It can be used with almost any blockchain that you implemented a backend for. We already have backends for Ethereum, Polkadot, and the Cosmos network. And potentially in the future, we are planning to implement additional blockchain backends, for example, for Fabric. If you want to support us there, let us know. We also look out what potential customers, for example, would need. We are also working on further developing our light client implementation on IoT devices, which might be then in the end a Rust implementation for very small devices, so that we can really deploy it on small resource constrained devices where the full Go library could not work. And then we have the protocols thought out, how we can enable the cross-chain transactions, but we have not fully implemented the functionality yet. And that's something that we are currently working on as well, so that we can really open a channel, like I explained, between a client on Ethereum and a client on Binance Smart Chain, for example. And that will be the target for, I think, Q1 next year.
Thank you, Matthias.
Yes, that's it.
Thank you for the very, very insightful presentation. And now we have already one question for you on the chat, and it's from Athalis. How would Perun differ to a layer 2 solution like Polygon?
Yeah, so I think Polygon has multiple, so correct me if I'm wrong, but I think Polygon has multiple different layer 2 solutions, and maybe they also provide some state channel technology there. So they might, to some extent, follow a similar approach. What makes Perun special is that we are not targeting one specific blockchain with our protocol. You can use Perun basically for any blockchain that you want. And if you have written an application with Perun that you usually run on Ethereum, it's pretty simple to port that application if you decide, okay, well, maybe Hyperledger Fabric is a very interesting blockchain as well, and customers might like it. You don't need to change much of your code to make it work on Hyperledger Fabric as well. So that's something unique about Perun. And I think Polygon overall, has a somewhat different scope. They do more than just state channels, and their state channel solution is also different, at least in this aspect, if not more. Yeah.
How about the performance of your network? Have you measured the performance?
Yeah, so so it might not have looked like it, because we needed to, in the demo that I showed, because we needed to manually sign everything. But we also have a CLI demo, which works on the command line, where you don't need to agree on all the signature generations. And we achieved that. You can actually download it. You can find it via our GitHub pages. And we achieve over 1,000 transactions per second there. So you can run it on your PC. You can run the benchmark command. It's described in the README, and you can see how many transactions you can do on your computer. But usually it's at least 500 per second, if not more. Yeah.
Isn't your Perun network a single point of failure between two blockchains?
If there's a point of failure between two blockchains, or?
Yes, it's also a centralized mediator, centralized proxy.
So we don't necessarily need that. The idea is that you can basically, for the protocol, it does not matter so much if you have a smart contract deployed only on one blockchain, or if you use smart contracts on, for example, two different blockchains with the same logic. The smart contract will always be the point of mediation, and there's no additional central party necessary. So you don't have one point of failure. If you are not happy with so for example, it could happen you you open a channel with a party that has funds on a different blockchain. You want to swap your funds from Ethereum with the person's funds from Polkadot. Then you need to deposit your funds on Ethereum into Ethereum Perun contract, and the other person needs to deposit their funds into the Polkadot Perun contract. And then they can transact on the channel. The channel will have a reference to the Ethereum chain and to the Polkadot chain. Basically, in the channel, you will see that now you have assets from two different contracts. And if one of the parties of the interaction goes away and does not want to talk to you anymore, then you can go, for example, this party might previously send you some funds and then deny to close the channel. But then you can go to the Polkadot blockchain contract and say, okay, here, I have a statement that is signed by this party that these funds should be transferred to me. And then you will be able to withdraw these funds on the Polkadot network to your Polkadot network account. So you need an account on each of the blockchains, but there's no trusted third party necessary to make these transactions work. They're atomic in the way that they are. I hope that made a little bit of sense.
Perun still is in the middle.
Perun is just a library. Perun is the technology. There's no party. The clients will run the Perun library, but they are basically independent. You kind of need to trust us as the developers that we implemented the protocols right, but that's the case with all software. So each client will run the Perun library on his device, and there's no middleman necessary to be trusted or so. There's just an interaction between two clients and the blockchains.
Matthias, there's actually like another question for you, probably like the last since the time. And thank you for actually answering to the other questions. Is Perun compatible with Flare or Cardano now or in the future?
Yeah, that's an interesting question. So Flare, actually, I don't know much about. So this is not necessarily on the roadmap. With Cardano, we talked, and there are plans. And they are also in favor of our project. They like it. I think this is, yeah, I can say this, but it's a bit more difficult so it's Cardano will be a smart contract system that is UTXO based like Bitcoin. And all the implementations that we did so far are like account based like Ethereum. I think also Fabric will probably be account based. So it's a bit more work than for the other backends, and this is why we're not so far yet, but it's thought to be on the roadmap for Cardano.
Great. So thank you, Matthias, for the answer. And we just have 1 minute more. So I would like to thank Matt and Matthias who participated and gave us their insights and introduced us to the Perun network and the book of Matt. And I also would like to thank you, David, for co-hosting. And thank you to all the attendees who have joined and engaged today. And I'll see you to the next Hyperledger meetup, Berlin. And to stay updated, you can just subscribe to the Hyperledger Berlin meetup page here in the chat. And stay tuned for upcoming meetups. Thank you and have a nice day.
Yeah, thank you for hosting. Bye-bye.
Bye.